Good morning, students. Today we will continue with our exercise 7.4 of chapter integral. And in the previous class, we have discussed about the concept that what we will be doing here. And now we will continue with sum number 10. And here in sum number 10, if you notice, we have integral dx by root of x square plus 2x plus 2. Now here in the denominator, root of x square plus 2x plus 2 is there, but if you remember, what kind of formula do we have? We have dx by root of x square plus a square. If I have this kind of integral, then we know the answer will be log of mod x plus root of x square plus a square plus c. But here the coefficient of x square is 1 and constant is separate. Here nothing like that is happening. So first thing that we are supposed to do here, again we have to make our integral in this form. So what we will do here, x square plus 2x, like that terms are present. So first we will use our method of completing the square, and once completing square is done, then we will have the coefficient term containing x. One term will be containing x and the other term will be completely constant, right? So what we will do here, we will use our concept of completing the square. X square will remain as such, this 2x will remain as such. Now in order to complete the square, what do we do? Coefficient of x, it is 2, half of 2 is 1, square of 1 is 1. So what we can do, we will add 1 and subtract 1, like that. So what we are doing, I have added 1 and subtracted 1. In this particular sum, if you even don't do this, you just write down 2 as 1 plus 1, then also purpose will be solved. But it is okay. With this sum, you can at least understand the concept here. So x square plus 2x plus 1. If I consider these three terms, it is giving me the identity of x plus 1 whole square, and 2 minus 1, it can be written as 1. Okay, now this x plus 1 whole square, it has come in place of this x square, and the value of a square is 1. So it's up to you. If you want, you can substitute this x plus 1 as y, because if I put x plus 1 as y, then the derivative dx will be dy only. Okay, so what we will do now, we will put x plus 1 as y, which implies when I differentiate both sides, I will get dx equals to dy. So our integral will become here dy divided by root of y square plus 1. Now directly we can apply this formula. Instead of x square, what do we have? Y square, and the value of a square is 1. We will write which is equals to log of modulus y plus root of y square plus 1 plus constant. Okay, now we will substitute back the value of y. What was y? Y is x plus 1. So here x plus 1 plus root of, and when here I put the value of y as x plus 1, right? X plus 1 square plus 1 plus constant. And what is this x plus 1 square plus 1? Actually, this is the same root which was given earlier. So we can write the same root here. It will be x plus 1 plus root of, because if you open the square, it will be x square plus 2x plus 2 plus constant of integration, and that will be our answer. So what we have to do, whenever in the denominator the terms are not given straightforward, x square minus a square, x square plus a square minus x square, or it can be without square root also. That means there is no square root in the denominator, and the terms are not given straightforward, it is quadratic type given. So we will always use the method of completing square so that we can separate the terms. Okay, so I hope this sum number 10 is clear to all. Now we will do the next one, sum number 11. and sum number 11. Here no root is given. The equation, the integral is given dx upon 9x square plus 6x plus 5. Now again we have quadratic in the denominator, but the coefficient of x square is not 1. So what will be the first thing to do? We will make the coefficient of x square 1. That means we can take 9 common. So here we will have, before completing the square, we will take 9 common. So it will become x square plus 6 by 9x plus 5 by 9. I hope everybody knows when we use the method of completing square, we have to make the coefficient of x square as 1. So what we are getting, 1 by 9 is outside, dx divided by, this is x square plus 2 by 3x plus 5 by 9. Okay, now in order to complete the square, once again what will be the method? Half of the coefficient of x, 2 by 3, half will be 1 by 3, square of 1 by 3 is 1 by 9. So what we will do here, we will add 1 by 9 and subtract 1 by 9. Now this 1 by 9 I will bring here. This 1 by 9 we will take with this term. Remember, if the coefficient of x or the term containing x is positive, that means our identity will become x plus a square always. And if the coefficient of x is negative, then our identity will become x minus a whole square. So here positive term we will bring, and this negative term 1 by 9 we will write down with 5 by 9. So what will become here? 1 by 9 as such, dx divided by x square plus 2 by 3x plus 1 by 9, and this 5 by 9 minus 1 by 9, and this 5 by 9 minus 1 by 9, it will become 4 by 9. Okay, I am repeating this step. First of all, we have made the coefficient of x square 1 by taking 9 common. And now in order to complete the square, coefficient of x, it is 2 by 3, half of that is 1 by 3, square of 1 by 3 is 1 by 9. So 1 by 9 added, 1 by 9 subtracted. Since the coefficient of x is positive, the positive term we will take here, right? Because our identity will become x plus a whole square kind of, and this minus 1 by 9 I will club with 5 by 9, which will give us 4 by 9, right? And now we will move to the next step. Let us rewrite the step that we have done on the previous page. 1 by 9 was constant outside. It was x square plus 2 by 3x plus 1 by 9. And here what do we have? 4 by 9. Now our square has become in the denominator. It can be written as x plus 1 by 3 whole square, and this can be written as 2 by 3 whole square. Okay, now again it is x square plus a square form. So either you put x plus 1 by 3 as y, or you keep it as such, because since it is linear, I can keep it as such, because this x plus 1 by 3, okay, instead of x square we have x plus 1 by 3 whole square. So this x plus 1 by 3 if I put, then dx simply will become dy, and this x plus 1 by 3 is becoming y. So directly if you want, we can write down the answer. This 1 by 9 will be as such, log of modulus, this can be written as x plus 1 by 3 plus root of, okay, here we were not having the root. Okay, so this formula we cannot apply, because let me take you the formulas we have here. I have written few formulas here. Whenever we have dx upon x square plus a square without root, as in sum number 11 there is no root in the denominator, then the formula is 1 by a tan inverse x by a. So it means our here in this particular sum, log formula will not come, but tan inverse is coming. It is x square plus a square, so it will become 1 by 9 it is as such 1 by a. What is 1 by a here? 1 by a is 2 by 3 tan inverse x by a. Instead of x we have x plus 1 by 3 divided by 2 by 3, and this is the complete angle plus constant of integration. If you get confused that how come x plus 1 by 3 is coming here, so in this particular sum, okay, if you want you can make the substitution to make it simple. We can write down here x plus 1 by 3 as y, so dx will become dy after differentiation. So our integral will become here 1 by 9 is constant as such. We will get dy upon y square plus 2 by 3 whole square. Now it is y square plus a square. Okay, so 1 by 9. Formula says 1 by a tan inverse y upon a plus constant of integration. Now you can put the value of y, and when you are putting the value of y, ultimately it is same as I have written here. Okay, so this thing will give us 1 by 9, 1 by 2 by 3, 3 will go there, so 3 into 3 we are getting 1 by 6 tan inverse the value of y when we are writing here, it will be 3x plus 1 divided by 2 plus constant of integration. When I take the LCM in the numerator denominator, 3 is getting cancelled, so 3x plus 1 by 2, 1 by 6 outside tan inverse of this. So this will be our answer for sum number 11. So remember again, whenever we have quadratic kind in the denominator, what we have to do, we have to use the method of completing square. Complete the square, separate the terms x square plus a square or x square minus a square. Accordingly we will just apply the formula and then substitute the value of that particular variable. Okay, and we let us do few more sums. Since sum number 12, it is constant is coming first and x square is having the minus sign, so let us do that sum as well. Or sum number 12, let me keep it for you. We can do sum number 14 also. Okay, now first I will give you the hint of sum number 13. Sum number 12 you people can do on your own, and now we will discuss sum number 13. Sum number 13, integral is given dx by root of x minus 1 x minus 2. Now here what is given, we have product of two linear brackets, right? X minus 1 x minus 2. Again we don't have straightforward formula. If I have x minus a x minus b kind of in the denominator under the square root, so once again what we will do, let us multiply and simplify it. We will get here x square minus x minus 2x means minus 3x plus 2. Now this is our quadratic which is in the denominator. Okay, again we have to simplify it, means we have to complete the square, right? So completing square method we will use, and in order to use that, once again what you people will do here, now if you notice coefficient of x is negative, that means the here it will become the identity will become x minus a whole square kind of. Okay, so again coefficient of x is 3, half of 3 is 3 by 2, and square of 3 by 2 is 9 by 4. So what we will do here, x square minus 3x, half is 3 by 2, square of 3 by 2 is, what will be that, 9 by 4 plus 2 minus 9 by 4. So the plus term will come here, minus term we will write down there, and when we simplify it will be x, this is 9 by 4 minus 3x. So this is a square plus b square minus 2ab, right? And this can be written as then minus 3 by 2 whole square plus. Now what is this coming? 4, 2 minus 9 by 4, 4 into 2, 8. So it will be not positive, minus 1 by 4. 2 minus 9 by 4. These two terms are giving minus 1 by 4. So this x minus 3 by 2. So if you want, you can put here, or you can do straightforward also, as I have told you. And when we differentiate both sides, we will get here dx equals to dy. Okay, so our integral is becoming dy upon root of y square minus 1 by 2 square. Root of y square minus 1 by 2 square. So this integral is of the form, which formula we will apply? It is dx by root of x square minus a square. Root of x square minus a square. So formula will be log of modulus x plus root of x square minus a square. So this we will write down log of modulus y plus root of y square minus 1 by 2 square plus constant. And now you can substitute the value of y. What was that? X minus 3 by 2 plus root of x minus 3 by 2 square minus 1 by 4 plus constant. So here this term, if you simplify, again you will get back the given original, this x square minus 3x plus 2 only, because this thing only we have made like that. Okay, so if you want, you can simplify it. It will become x square minus 3x, then plus 9 by 4 minus 1 by 4. 8 by 4, 8 by 4 is 2 only. So here what we will get? Log of this term, if you want, you can write down as such also, or it will become 2x minus 3 divided by 2 plus root of x square minus 3x plus 2 plus constant of integration. Okay, so you can leave the answer here also, or you can leave the answer here also, but this term, it is always good to put it in the given original form. What was given, the same thing will come always here according to the formula. So here we have applied the formula. Okay, I hope this is clear to everyone. And similarly, you people will do sum number 15, then you have sum number 16. Okay, so we will be doing few more parts we can discuss. This was 13th sum. Sum number 12 I have left for you people. We will discuss here sum number 14. 12th, if either I do 12 or do 14, they will be same sums. So let us do sum number 14, and 12th you people will be able to do, right? So let us continue with the sum number. Yes, so we will continue with sum number 14. I have written the statement. It is dx by root of 8 plus 3x minus x square. Now the coefficient of x square is negative. Okay, so remember, our identity or our formula will become a square minus x square kind of. So whenever the coefficient of x square is negative, our identity will become a square minus x square kind. That means formula. Similarly, in sum number 12, there also coefficient of x square is negative, then also it will become a square minus x square kind of. Okay, so let us again do the same thing. What we are supposed to do, we will complete the square. But before that, I am writing here 8 minus sign I am taking common, x square minus 3x. What I have done, I have combined the terms containing x and x square. So minus sign I have written outside, it will be written x square minus 3x. Now we will complete the square. The coefficient of x is 3, half of 3 is 3 by 2, square of 3 by 2 is 9 by 4. So 9 by 4 we will add here and 9 by 4 we will subtract. So again, one important thing you have to take care of, we are writing 8 minus here x square minus 3x. Now what are we supposed to do here? We have to add 9 by 4 and subtract 9 by 4. If I have written here plus 9 by 4, I am writing here plus 9 by 4. Actually what is done, because minus sign is there, here it is not the positive term gone, it means here the negative term has gone. Okay, because in order to complete the square, definitely plus 9 by 4 will come here and minus 9 by 4 will go with 8, but this minus sign is taken already common, so this minus sign will make all the terms negative which are inside the bracket. So when I write down plus 9 by 4, actually it is minus 9 by 4. Okay, and this plus 9 by 4, okay, here I am writing first of all we will write down outside the bracket. But so this 9 by 4 will go with 8. So what will happen? We will get dx by root of 8 plus 9 by 4 minus, now x square minus 3x plus 9 by 4, it will be written as x minus 3 by 2 whole square. So this is dx divided by root of 8 plus 9 by 4. 8 into 4 is 32, 32 plus 9 is 41 divided by 4 minus x minus 3 by 2 whole square. So this 41 by 4 can be written as root 41 by 2 whole square. So the formula that we are going to apply, it will be dx by root of a square minus x square. Okay, dx by root of a square minus x square. So which formula it will make? It will make sine inverse formula. Okay, so which formula we are getting here? Sine inverse. So the formula was, if I have dx by root of a square minus x square, it is sine inverse x by a. Okay, so here what we will get, this will be equals to, again I am repeating, this term is a linear, x minus, the coefficient of x is 1. So if I put this x minus 3 by 2 as y, dx directly will become dy. So straightforward we can write down the answer, it will be sine inverse x by a. Instead of x, what do we have? X minus 3 by 2 divided by a. What is a? Root 41 divided by 2 plus constant of integration. So when we simplify it, it is becoming sine inverse 2x minus 3 divided by a root of 41 plus constant of integration. Okay, so this will be our sum, and I hope it is clear what we are doing. Whenever coefficient of x square is negative, we will take minus sign, combine the terms of x and x square. Now when we are completing the square, half of coefficient of x, that is 3 by 2, square of 3 by 2 is 9 by 4. So 9 by 4 we have to add and subtract. If I am writing here plus, definitely when I am doing that, plus term will always go with the terms they here, because we have x square plus a square minus 2ax or plus 2ax. So this term will be positive. But outside minus sign, that means actually negative term we are writing here. So the positive term 9 by 4 will go with 8. And 8 plus 9 by 4, it will be 41 by 4. And here a square minus x square formula we will apply, that is sine inverse x by a. Instead of x, what do we have? X minus 3 by 2. So that we are substituting. Right? So this is your sum number 14. Similarly, you will do sum number 12. Sum number 15 is just like sum number 13 that we have done. Okay, and sum number 16. Now in sum number 16, what we will do, you have to make the coefficient of x square first of all 1. So you will take here 2 common. That means 1 by root 2 will come outside. Okay, so let me give you the hint here. Sum number 16. Hint, the integral is given here 4x plus 1 divided by root of 2x square plus x minus 3 dx. First of all, in the numerator you have the linear function, and it is just like same sum. I think in the previous class we discussed sum number 7. Same way we will do here. First of all, linear function is given in the numerator. We have to separate the terms. It will be 4x divided by root of 2x square plus x minus 3 dx, plus, because plus sign is there, plus here dx upon root of 2x square plus x minus 3. So this integral we can mark it as I1 and let it be I2. The whole integral is capital I. So if you want, you can mention here it is I1 and this is I2 integral. First you solve I1. When we solve I1, what is happening here? You have to just okay, we can do here, instead of separating even, if you notice one thing, it is coming 2x square plus x minus 3 and the numerator is 4x plus 1. So if you put directly 2x square plus x minus 3 as y, the derivative of 2x square is 4x, the derivative of x is 1. So there is no need even to separate the terms, right? If I put this 2x square plus x minus 3 as y, this 4x plus 1 dx, directly it is making dy. So there is no need even to separate. Okay, so I just did it like that, means separating the terms, but when you observe it very carefully, there is no need to apply this method. It is coming straight forward. There is no need to apply the formula of exercise 7.4. Directly answer is coming. So what we will do here, let me take you to the next page. In this sum number 16, directly you will put x square 2x square plus x minus 3 as y, and when you differentiate both sides, it is 4x plus 1 equals to dy by dx. So our integral will become here dy divided by root of y, and everybody knows how to integrate. The power you can write here y raised to power minus 1 by 2 dy. So we increase the power by 1 divided by increased power. So minus 1 by 2 plus 1, that means it will be y raised to power 1 by 2 divided by 1 by 2 plus constant. So it will be 2 root of 2x square plus x minus 3 plus constant. Straightforward answer is coming. Okay, yeah, so sum number 16 as well done. Now sum number 17, here I is given x plus 2 divided by root of x square minus 1 dx. Now x plus 2 is not the derivative of x square minus 1, okay, but x is coming when I differentiate x square, because when we differentiate x square it is becoming 2x. So here we will separate the terms. It will be x square upon x square minus 1 dx plus 2 upon root of x square minus 1 dx. So here let it be I1 integral and I2 integral. So we can mark it as 1. This is capital I. So when we solve I1, it is x dx divided by root of x square minus 1. So here what we will do, if I put x square minus 1 as y and I differentiate both sides, we will get 2x equals to dy by dx. That means the value of x dx will be dy by 2. So I1 will become 1 by 2 is outside. It will be dy divided by root y. Just now we have done the integral dy by root y. It is 2 root y. So straightforward here I am writing the answer. This 1 by 2 is as such, it is 2 root y plus constant. So root y answer will come, that will be root of x square minus 1 plus constant. So this is the answer for I1. And what is happening in I2? If I write down 2 outside, it is dx by root of x square minus 1. Dx by root of x square minus 1 means dx by root of x square minus a square. And we have some formula number 4, log mod x plus root x square minus a square. So here direct formula is applied. Here we are making the substitution to get the integral. Okay, so what our I2 integral will become? Let me take you to the next page. So our I2 integral is, 2 is constant, we can write down outside, it is dx by root of x square minus 1. So here 2 is as such, and dx by root of x square minus 1 means dx by root of x square minus a square. And what is the formula? Log of modulus x plus root of x square minus 1 plus constant. So this is the value of I2. Therefore the answer for I, it will be the value of I1 integral. And what was that? It was in root of x square minus 1 plus the value of I2 twice log modulus x plus root of x square minus 1 plus constant of integration. This will be our answer. And this is sum number 17. Okay, similarly sum number 18. First of all, separate the terms. In one you can go for here also sum number 18. Let me show you one interesting thing is here. Like it is given 5x minus 2 divided by 1 plus 2x plus 3x square dx. Okay, so what you have to do here, 1 plus 2x plus 3x square. Now if I differentiate this, I am getting 6x plus 2. In the numerator I have 5x minus 2 plus 2 I can write down by adding and subtracting 2, but this 6x is coming. So what you people will do here, you separate the terms, and like I will write down here, it will be 5x divided by 1 plus 2x plus 3x square dx minus 2 divided by 1 plus 2x plus 3x square dx. So this is capital I. We can mark it as I1, and this we can mark it as I2. In I2 integral, definitely 2 is constant outside, and here you will come using the method of completing square. But when you complete the square, coefficient of x square you have to make 1 by taking 3 common. And here in I1, what I can do, 5 if I write down outside, it is x dx divided by 1 plus 2x plus 3x square. Now in the numerator x is there, but when I differentiate the derivative, I should get 6x plus 2. This x I can easily make as 6x plus 2. For that what we will do, 5 is there, I will multiply and divide by 6. I am getting 6x divided by 1 plus 2x plus 3x square. Now 6x has come, I should get 2 also, so I will add 2 and subtract 2. So what we are getting, 5 by x, this 6x plus 2 I can combine like this dx minus this 2 I will write down separate minus 2, but this 5 by 6 is already there, so minus 10 by 6 here dx upon 1 plus 2x plus 3x square. Okay, so this is becoming 5 by 3, and same you will have here. So this integral, that is I2 integral, and this part integral of I1 we can club now, and here derivative upon function. So whenever you have derivative upon function, that means if I put this as y, this is becoming dy. So remember, whenever you have f dash x upon fx integral, it will be log of fx, straightforward. Okay, so it can be written then 5 by 6, okay, log of mod 1 plus 2x plus 3x square. I am writing it directly. I will explain how we can do that. Minus 5 by 3, and this is what? It is integral dx upon 1 plus 2x plus 3x square. Okay, now one new thing I have done here. So remember, whenever we have this kind integral f dash x upon fx dx, it will be always log of mod fx plus constant. Okay, because if I put fx as y, this will become derivative. So it will become 1 by dy upon y, and the integral of 1 by y is log. So whenever we have f dash x upon fx, it will be log of fx. This formula we can use now directly. Okay, because as we are moving to the next exercises, the things or the functions will become a little complex. So we can simplify our things with the help of these formulas. You people can do complete this sum number 18. Okay, and I want you people to do till sum number 18 today. You people can do it easily, or if you can complete till sum number 20 also. The remaining sums you can discuss or you can do in the next class. Okay, I hope you people are getting the method, that whenever we have quadratic, we will use the method of completing square to complete that in order to apply the formulas. Okay students, thank you.